In this video, I'm going to work through the process of integrating the sine of the square root of x. So here at the beginning, we're going to go ahead and use a nice u-substitution for our square root of x. So I'm going to say u equals the square root of x, which means when I differentiate both sides, I'm going to get 1 over 2 times the square root of x dx. And of course, solving for dx then is going to give me 2 times the square root of x times du. And I'm going to kind of push this over to the side for a second. We'll come back to that in a moment. So let's go ahead and rewrite our integral now. So it's going to be the integral of sine of u, and then we've got this, let's put that in parentheses, and then we have our dx, which is 2 times the square root of x du. Well, we kind of have a mixture of u's and x's, so that's no good. But the square root of x here, I knew is actually u. Okay, so I have the sine of u times 2u du. And now this is a much better situation because everything is in terms of u now. Let's go ahead and rewrite this a little. This 2 I'm going to bring out front, so 2 times the integral, and I'll say u times the sine of u du. And now let's go ahead and use integration by parts on this. Integration by parts usually uses u and v, but I've already have u being employed here. So let's go ahead and maybe use f and g just for 2 other letters. So if that's the case, then my integration by parts says the integral of f dg equals fg minus the integral of g df. Okay, so that's our little formula here for integration by parts. So that means I need a value for f, which then I'll differentiate, and I need a value for dg, which then I'll integrate. So we're going to ignore this 2 out front. So the f would be u right there, so when I differentiate both sides, it's just du. So the leftovers then must be sine u du, and that'll be my dg. Integrating that will give me a negative cosine of u. Okay, so that means this integral right here is going to be, well, f times g, so negative u cosine u, minus the integral of g df, so g df. So it's negative, so the negative here and the negative can cancel. So this is just cosine u du. Okay, well, this just stays the same, and the integral of cosine is going to be sine u plus c. And of course, this whole thing had been multiplied by 2, so I can put this 2 out front. And remember back from the beginning, my u was actually the square root of x. So let's go ahead and do all this together. So negative square root of x times cosine of square root of x plus sine of square root of x plus c. So that means when I run this through, it's negative 2 times the square root of x times the cosine of the square root of x times 2 times the sine of the square root of x plus c. So here's what you get when you integrate the sine for the square root of x. So we just got done integrating the sine of the square root of x, and I got this expression. So let's go ahead and differentiate it and see if we get the sine of the square root of x back. Okay, so here I have the product rule, so I'm going to say the derivative of the first times the second, and then the first times the derivative of the second, and that's the product rule there, and then plus, let's see, 2 cosine times the square root of x over 2 times the square root of x. Okay, so a lot of stuff going on here, but of course a lot of stuff will cancel as well. So the 2's here will cancel. Looks like the 2 radical x's will cancel. The negatives will cancel. The 2's will cancel. So I have cosine times the square root of x over the square root of x, and then plus sine of the square root of x, and then plus, oh, by the way, this was a minus out front here, and then cosine of the square root of x over the square root of x. So of course these do cancel, and I'm left with the square root of x. So I know that this integral that I found originally is correct.